Okay.
hope. I'm about to hand off control to Mr. Archer. And I got through all of the lesson this afternoon. So
Okay.
the lab should be a little smoother for you.
Yep. Sounds good.
Okay, you can take control of the screen and do your thing. You're being recorded, so everybody don't be mean to them. Be mean in the chat box because I'm not saving the chats. So that's where to be mean.
I always have such a hard time finding the stupid share screen interface somewhere across my 30 monitors.
That's all you computer science guys. That's your own fault. I have no sympathy for you.
It is a self-inflicted wound. All right, is everybody able to see my screen and hear me? Okie dokie then. Well, let's get started. Today we're going to be talking about input and output. Now, we've been using output basically the entire time. It's extremely difficult to have a program that's useful and not have any output. We also messed around with input in the previous lab because I can't help myself from adding stuff that we're going to be doing later. So input. Useful programs take input and generate output. So we're going to practice capturing input from the keyboard. Now, input to a program can come from a whole host of places. Generally, when you're learning a program or learning a language, I guess, it's going to come from the keyboard. After you learn to get input from the keyboard, usually you start taking it from a file. Well, you can take it from a whole bunch of places. Anything that can be a stream in the operating system. And by stream, I don't mean like Fortnite or something. I mean, I'm moving the mouse around, and what that is doing is there's a stream opened in the operating system that's saying I'm moving it to the left, and there's a little bit of up and down. And every frame, there's a place I put move it. Same thing with clicking it. Same thing with a keystroke. Same thing with a file. You can do stuff with web interfaces. Input can come from all over. But for now, we're going to be dealing with keyboard. So I'm going to take input. Input allows the user to type from the keyboard and then press the enter key. And it will turn that into a string. It will take it as a string, really. And then we're going to store it in a variable. And then we're going to print out the type of that variable, and we're going to print out the value of that variable. All right, so let's take an input. Say hello. Says it is of type string and value hello. I'm going to run the same thing, and I'm going to put in a number. Now notice it says it is of type string. That's because, as I said, we take input as a string. If I would like this to be an integer, I need to cast it to an integer at some point. Here's an example of casting our input. We're going to force it to be a string. So if you found some way to put input, and I'm sure you can enter some series of characters that would do what you want. But what this will do is say, no matter what our input is, if it's not a string right here, cast it to a string here. So now the value stored in the variable, we take the variable and make sure it's a string and print out that, yep, it's a string and its value. There's a lot of stuff we can do with strings. What we're going to do here is we're going to make sure that, well, we're not going to make sure, we're going to force every letter in the string to be uppercase. So I can type H-E-L-L-O with a couple capital letters in there. Oops. I guess that's fine. I'm going to do it the other way around. Now, E-L-L are lowercase. But when I run the program, it comes out as uppercase. That is because of the upper method right here. Now, what is a method? Well, prize is a variable. It is, moreover, a string variable. Now, the string built in Python has a couple different methods. What's a method? Well, if I have an object, I can specify a couple things that the object can do. So if I say I have a square object, I'm going to say there's an area method. What is this area method going to do? It's going to take the length, take the height, multiply them together, and give them back. Also, I'm probably going to say a perimeter method. What's the perimeter going to do? It's going to take the length times 2 plus the height times 2 and give them back. Well, the string object has what is called the upper method. Now, a method always needs 2 parentheses like that if you want to call the method. And that, the doorbell. I'm not expecting anybody. That's weird. You'll have to ignore the dog. Sorry. So if you want to call the method, you do need the 2 parentheses. And that is what we want to do. So we're going to call the method that makes everything in a string uppercase. And that's what happened. All right. We want to modify case 3 to make the fries variable numeric, integer and float, and then run the script to validate the modification. Okay. Well, we do everything we were normally doing, but we add this cast on the variable of integer. We're going to say do everything normal, take uppercase, blah, 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 and now cast the whole thing to an integer and print it out. Well, let's see what happens. H-E-L-O. Kind of have an issue here. We cannot cast this string to an integer because it doesn't have a representative integer. Somebody give me a input string that would probably have a correct casting. $42. Okay, we'll try that. All right, works fine. So it comes in as a string. We cast it to a string and make it uppercase. Well, digits don't have uppercases. And then we cast that string to an integer, and then we print it out. Works pretty well. All right. There is something else about the input function that we should talk about, and that is the prompt. It's a good idea to tell the user what to input. As we have seen, we've been running input, but if you, instead of running this from your console or from your notebook, let's say you actually have the executable and you run it, all you're going to get is this, a blinking cursor or a blinking line thingy. It doesn't tell you anything. Well, we can do that. If you put a string into the input function, it will print that string before waiting for input. So wait for a number, put in the number, got it. What we're going to do is we're going to sort of build a machine that can, or a program that's asking the user if they want fries at their order. So let's build it bit by bit. Give a prompt. And now this prompt generally says that it's taking a Y or an N. Anything else is probably not going to be very good input. So I input an N, it's fine. Additionally, I'm going to add on making it uppercase in case they do a lowercase, because the uppercase Y and the lowercase y are different characters. Okay. Another thing that's useful is that instead of typing the entire prompt into the input function, we can store that prompt in a variable. And now I can just put that variable in the input. So everything I was doing before, but I'm just using a variable. Cool. What we have on the screen here is I might be able to zoom. I don't think so. This is a screenshot. I guess the word would be a still frame from the film The Terminator, 1985. Very good film. In this particular moment, the Terminator is, I believe, doing some maintenance at a hotel room. And the owner or the landlord or whatever comes to the door angry and says, "You better let me in." And we see the Terminator's vision. The Terminator has to pick from some responses here. And we're going to emulate that. We have a list of responses. We're going to pick one. Let's see. There is a question. I'm trying to input a variable because it says it's pending input. All right. This is going to be a issue that you're going to have over and over and over. We had it this morning. We'll have it again. If you run a cell that takes input and you don't finish this execution, you're going to have a problem. So this is expecting me to hit enter, and then I will move on to the next one. Okay, cool, got it. But what if I don't hit enter? What if I don't finish it? Well, here's what happens. Well, that's kind of weird. It didn't actually run. That's kind of weird. It didn't actually run. Where did everything go? Notice how my kernel is busy. If you don't finish the entire thing, give an input and go on, you're going to run into problems. So how do you fix that? You got to stop your kernel and restart it. Okay. So we're going to build something kind of like this. Here is our list of possible prompts. It is a list of 1, 2, 3, 4, 5, 6, 7 different strings. And what we're going to say, we're going to pick the one at position 4. And we're going to print that out. Well, actually, we're going to make that the prompt for the input, and then we're going to take whatever input we have. Can someone tell me what the prompt is going to be? The string at position 4? Go away. I think so. Well, remember Python, we count from 0. So 0, 1, 2, 3, 4. So let's find out. It is please come back later. All right. Yep. That's the one. All right. Well, what if instead of saying we want the 4th one, or the one at position 4, we're going to pick one randomly? We can do that. Now we have, how many did we say? 1, 2, 3, 4, 5, 6, 7. The way random range will work is it'll go and it's going to pick you a random number between low and high, but it doesn't include the actual number. It goes up next to it. So this is 0 through 6. So it'll give us 7. So what we're going to do is we're going to get a random number between 0 and 7. And we're going to print out what that is. So 4, 2, 0, 1. I can do something a little neat here. While I sent in print, I'm going to do this. Now this is what is called a loop. You don't know how to do this yet, and that's fine. It's not crucial to the lesson. This is just going to save me hitting a keystroke 10 times. So I'm going to say I is equal to 0. And while I is less than 10, I'm going to print out a random number. Okay. Oops. What did I do? What? Yep. In Python, it's something different, isn't it? Okay. So I'm printing out 11 random numbers here because this is the first one. So I get 5, 6, 6, 0, 1, 4. And if I run it again, it's different. So as you can see, it is randomly making some numbers. Cool. Now let us abuse this to, instead of printing out random numbers, print out a random prompt. So we're going to take the prompt, going to put it into our code. Now, could someone tell me, I'm going to need to print something here. How do I print a random element of this prompt list using the random number I generated above? I stored the random number into the my prompt variable.
You could, yeah. No. That's one of the ways.
What should I put here? Well, I want something from this list, right? If I have a list, oh, well, someone gave me something. Yeah, that works. I totally dig that. So instead of putting the list name in here and then trying to index it, Christopher has said, well, we don't need to do this again. We already have I guess that's fine. That's totally fine. What we're going to do is we're going to take input from the user. And from that, we're going to say, here's my list and here's my random number. I'm randomly going to get you a prompt from the thing and I'm going to take your input. Let's run it. What am I doing? This needs to go away. Yes, it is. Okay. No. Okay. Please come back later. So we're getting a random element from our prompt list. All right. Now, let's put all that together in something that actually makes sense. Suppose we're building an automated food service program. If you recall from real life, when you complete an order, the cashier always asks if you like fries with that. Let's script the interaction and give either a yes or no answer from the customer. So we're going to say thank you for the order. We're assuming we've already got the order done. We ask if you want fries. Now, in the case they say yes, all right, here's a excellent. If they say no, we're going to really try to push the fries because we make a commission. So we're going to really try to push them and ask them again. If they say yes, print this one out. If they say no, say, all right, no fries, and then call them cheapskate. Now, if they give something other than a yes or a no, our program can't handle it. So we need to quit. The program needs to quit. All of that is built into this nested if statement here. We're going to print the first part of our statement, which is thank you for the order. Now we're going to take input. Now notice we have everything on one line here. This is exactly what was happening here, except we put it onto one line. It might look intimidating, but it's really not that bad. It goes from the inside out. First thing we do, we're going to take the part of statements at position 1. Position 1's right here. So that's the string, and that's going to be the prompt for input. Okay. Now we do that, cast that to a string, and then we uppercase it. That's just doing 3 things at once. All right, and then from there, fries, if they get the Y key, that means we want the fries. We print out the thank you statement. Otherwise, if it's an N, we really do try to push it again. So we run this. If they say yes, give them the thank you. If they say no, call them a cheapskate. If we get anything other than a yes or a no or Y or an, we're going to print we'll call it an error message. All right. Would you like fries with that too? No, because I am watching my carbs. Would you really, really not want that? No, I don't want it. Go away. Now notice I entered a lowercase n, and an uppercase n and a lowercase n are different. But because of the upper, the system has it stored as a uppercase n, so it's totally fine. All right. So no fries, and we get called a cheapskate. Very cool. Now, what if I don't give the program an input that it's expecting? What if I just say no, go away? Well, that's not something I was expecting, and I didn't enter a Y or an N. They can't handle the ambiguity, and the program quits. All right. In these examples, we don't operate on input that much. However, let's conclude the beautiful number example and do something with it. Alrighty then. So we're going to take input, store it in a variable. We're going to take that variable, cast it to a float, store it. And then what we're going to do is we're going to print a weird sentence here. And then we're going to apparently print the number itself, and then we're going to print the number times the number. Now, what's actually going on here, and we'll see a little bit later, is that this is very similar to the following. Oh, I need this quotes, don't I? Need that. And I need that. And I need that. All right. All right. Now this is the Syntax I use when I'm just making up normal nonsense because it's quick and simple. We get more power from doing what's going on here. But from a visual perspective, they're doing the same thing. I'm going to print out the string, the beautiful number, and then I have my variable, right? Print out my string, a space, my variable, another space, squared is, space, and then my variable times my variable. That's exactly what's going on here, because this %3f is basically a placeholder that we're telling the output, saying the beautiful number %. Oh, I got to wait for a variable. What's my variable? Well, we'll go to the end of the sentence. It's right here. It's the thing before the comma. All right, go back to what I was doing. Squared is, oh, I got another one. Well, what's the second one? It's this. All right, so that's what's going to happen. We're going to print out, somebody give me a beautiful number. $92. All right, we can do that. All right, the beautiful number 92 squared is 8464. Okie doke. Now, here's what we're going to do, and I'm not going to mess up. We need to approximate the square root of some numbers here. Now, we're not going to write a program to do that. We're not going to get the square root. We are going to approximate it. Now, what does that mean? Well, can someone tell me? Well, it's already on the screen, so I don't want to use that one. Yeah, sure. What's the square root? 3 is a prime number, right? Meaning that it only is divisible by 1 and 3. Can someone tell me the square root of 3? I'll even make it easier on you. Is the square root of 3 an integer? Well, Hazim already put in the square root, and it is obviously not an integer, which means that if you are trying to get, you're asking a human what's the square root of it, they're going to have to do some math. So that's what we're going to do here. We're going to approximate the square root of some numbers, and some numbers have an easy square root, so the approximation is not hard. So let's do it. We're going to use the stuff above to approximate some square roots. Now, what's I think the best way to do this, instead of me having to type a whole bunch, let's do 100. What should we say is the first thing we're going to be using? Oops. We're going to be using this stuff here. That's the tool we're going to use. All right. What's the first number we should put in? What do we think is a good guess for the square root of 100? 10? Okay, well, what is 10 squared? 10 squared is 100. Hey, look at that. We got it on a first shot. Now, what made you say that the first one we want to go with is 10? Because you knew the square root of 100 was in. Cool, works for me. All right, let's do 4. Someone else tell me what's the first number we want to try as the square root of 4? 2? Okay, we can do that. Turns out the square root, or the 2 squared is 4. All right, we're done. Well, let's try 2. What's the first number I should try for the square root of 2? Nope, that's not a number. Someone says 1.4. What on earth would you choose 1.4? That's kind of weird. What made you think that would work? It's not 1, it's not 2, it's not an integer. We've been using integers so far. What made you think of that? Now, so Joshua put in a 2 to the power of 0.5. Yep, that'll do what we're trying to do. But the point of this is we're not actually calculating the square root, we are approximating it. And this example is going to give us a good reason, because the square root of 2 is an irrational number, meaning you can't write it on the screen. There is no program that can print the square root of 2 because the decimal points go forever and ever. So what we're doing here is we're approximating. We're not actually getting the square root. Sometimes we'll get it, sometimes we won't. So what made you think 1.4 as opposed to, let's do the following. What if I start with 1? Well, 1 squared is 1. Says it's not 1. Okay, I'll go to 2. 2 squared is 4. Well, 1 is too low and 4 is too high. All right, well, let's split the difference. What about 1.5? 1.5 squared is 2.25. Hey, that's better, but it's closer than anything else. And so that's kind of the method I'm assuming you got to 1.4 with. So I was hoping you would enlighten me, but that's fine. So we got to 1.4 using this method. What's the next number we should try? Because 1.96 is not quite 2. If we can get within 1.99, then I'll call it good. So 1.4 got us 1.96. What should we try now? 1.1415. Now that is very specific. How did you get something so specific? That's pretty good. Definitely within the area. Yeah, so the thing I'm trying to get across here is you guys are doing the thing I'm trying to show, which is good. But I need to show it for the entire class. So I'm assuming what you did is 1.4 was close. So you go up to like 1.45, and that's too much. So you go down a bit, 1.42. That's pretty good. 1.41, and then 1.415. All right, let's do that process again. But this time for 204.490. And nobody please do exactly what he just did, but it's fine. How about this? I will give you something to start with, and we'll go from there. All right, 10 squared is 100. Okay, that is not what we want, and it's way below. Can someone give me a next number to start with? What's something we should try with? Try 200. 200 squared. Yep, that is 40,000. 40,000 is a little on the high side of this one. All right, so 200 is too high. 400 would be going in the same direction. So we got to guess that was too high. We don't want to go any further. So Colin says to try 13. All right, we'll try 13. 13 squared is 169. So we went below or lower, but we're closer than we were here. So I'm totally okay with that. So 13. So from 13, what should we try next? There's a very obvious next number in this pattern, but any number is fine as long as it's greater than 13. 14, yes, that's the one. 14, simple is good. Okay, 14 squared is 1.96. Wow, that's really close. What should our next number to try be? 15, yep, sounds pretty good. 225, so we went over, but we do know that we have the integer on the left and the right hand side of what we got here. So 14 is 196. It's only like 8 off. And 15 is what, 20 off, which means 14 is a lot closer. So the next number we want should be closer to 14 than to 15. Now earlier, Jack said 14.3, which sounds good to me. Let's see what it is. 14.3. 204. Hey, well, there it is. There it is. That's 204.490. Yeah, I would have started with probably 14.5 and then gone to like 14.25 and then 14.3 would have come along. But any method you want that is between 14 and 15, that's fine. Now, what we will learn later is, notice how I had to do this a whole bunch. If I were to put this into a loop, I could make this completely automated. so we don't have to sit here and do it ourselves. All right, that's input. What about output? Well, later on, we're going to learn about outputting to a file, but for right now, we're going to be printing to the console, and the console is this thing here. So what's my name? Let's go with that. Here's the console. So here is just a very simple print program with some interaction. It asks you your name, you give it back. We can also output values from a list, just like we had before. Or we can have a numeric list, we can print those out. Print out the list itself, and the type of it is list. We can print a blank line using the \n escape sequence. Now, I talked about an escape sequence last time. What is an escape sequence? Well, it's something, the \/ is the escape character, and the next character is what tells the system what the sequence is going to be. So to the program, that is one character. The \n is one character. It's the same kind of thing as x. X is one character, \n is one character. And even though I have to use 2 keystrokes to get to it, the system thinks it's one character. What is the \n character? It's a line. It's a blank line. It is a end my line and go to the next one. There's a bunch of these actually. Here's one. T. Does anybody know what this one is? \T. You could guess. Guesses on this one are totally fine. Indent. Yeah, it's tab. So that pushes the X out one tab. Here's an example. Let's build a script that asks the username and says hello, skips 8 lines, and then identifies ourselves as the Terminator. All right, let's do that. We want to prompt for the name. We want to echo the name. What the heck is echo? It is the same thing as print. Echo is the actual syntax for Unix, and it's been around forever. For most intents and purposes, echo and print are the same thing. Then we want to add 8 lines of blank and then identify it as the Terminator. All right, so we take the input and echo the name. We can do that. What's your name? Okay, prints my name. That's all it does. Next thing we do is add 8 lines. Okay, got it. Now we want to say we identify as the Terminator. Now it's going to print out an entire string here. Notice the 3 quotes lets me do multi-line, but not a big deal. But this is all just one big string. It can't really be modified. Okay, 8 lines and then the output. But we can do better. What we can do is I can take that %sign that we were using before and make our string actually vary depending on what my name is. Now, as I was saying, the way it works is the system's printing out my string and it sees this and it's like, oh, I need to put a variable in here. What variable do I need to put in? Well, it's going to be at the end. It's this one. So it's going to say, hello, variable. My name is blah, blah, blah. And then, yeah. So as you can see, it says, hello, Josh. My name is Bender. I'm a Cyberdyne Terminator Model 101 disguised as a bending robot. My favorite beverage is Albi Bach. Have you seen any living humans around here? Please insert girder. And then it prompts me for a number. And this is exactly what we were doing before. It's going to be doing the beautiful number thing. Using the same syntax we had earlier. Anybody have any idea what this 0.3 is about? Yes, it is 3 decimal places. If I were to change one of these, that's probably not a good one. If I change one of these, what I'll get, what's the square root of 2? Oops, it's doing squared. I can fix this. All right, so I get 5 decimal places over here, and I get 3 decimal places over here. Last thing we'll kind of look at is the ability to change the end of your line. So by default, the default end of line of a print statement is \n. So it's a new line, but I can make whatever I want. I can make it a space. I can make it an exclamation point, just like that. So I have two lines, two print statements, making what looks like one line, even though it's actually not. It is, well, let's try this one. Make whatever I want. Two print statements, two prints. And notice that this symbol and this exclamation symbol are nowhere in the actual strings. We actually already did this, messing with the 0.3. So why are the prints on the same line? Very good question. It is because the default, all right, so the way Python works, this is what is called overloading, is every print function has an end, and the end is what goes at the end. Now, if I don't provide it with a specific end, it has a default value. And the default value is \n. What if I put a \n in here? Well, there's an invisible \n right there that you can't see, because \n means new line. So this is the same thing as leaving it alone. But if I change end to be, imagine there is a new line here, then that's what we'll get. Now here's an interesting question, at least one to me. Oops. Input, give value for end. All right. What would happen if I ran this? Someone give me a value for end. What do we want the end key to be? Or the end character. I guess it could be a string, really. I mean, it can be anything. It prints in just like this. But notice that for the first one, it uses the one I told it to. But for the second one, it didn't. It didn't put a question mark here. That's because the inside of the function, this one is more specific. It says to use this one instead. Okay, that's everything in the lab. Let's look a little bit at the homework. Okay, you have your usual last name, first name. Here's what we got. We have a treasure map. Now, this doesn't look like any treasure map I've ever seen, but we can work with it. Eventually, we're going to write a program to explore the above matrix for a treasure. But first, let's understand how it works. The values in the arrays are clues. Each cell in the matrix contains an integer between 11 and 55. For each value, the tens digit represents the row number and the units digit represents the column number. So this is saying row 3, column 2. For example, starting the upper left corner at row 1, column 1, right here. Use the clues to guide your search of the array. So this says go to row 3, column 4. So row 3, column 4. This says go to row 4, column 2. All right, row 4, column 2. It says row 1, column 5, row 1, column 5, so on. The treasure cell is a cell whose value is the same as its coordinates. So if this were to say 1, 1, okay, where do I go next? I go to row 1, column 1. Well, that's where I am. So this must be where the treasure is. The program must eventually read in the treasure map and find the output, but that's not what we're doing right now. We're just learning to do some input. This builds the treasure map. You don't need to change that at all. What we need to be able to do is you need to write a program that takes input from the user of a row number and a column number. You need to return the contents of the treasure map at that position. So here's an example. What is the value? What is the value at row 1, column 3? Okay, row 1, column 3, it's 32. All right. Got it. But this right here is what is called hard coded. Row is 1 and column is 3. I want this to be able to be input to be anything 1 through 5 or whatever. You might even want to handle invalid input, but who knows? What about this one? What's 34? All right. And then what's a 3-4? It's 4-2. What's a 4-2? It's 1-5, so on and so forth. So step 1, make a program that can take input that's not hard coded. And step 2, use that script. And just like we were doing for the square root, keep doing this until you find the treasure. So keep doing this until I say 4-2, and it gives me back 4-2. Except it won't be 4-2, it'll be some other numbers. Okay. That is the lab and the homework. So any questions, comments, concerns, whatever? I'm confused with what you want us to do in the first part of the homework. Okay. Well, let's say I want my program to start at 5, 5. Okay. Well, it didn't do it. It started at 1, 3. In fact, I'll even make it easier to see. Print checking map at position row column. Okay. All right. Checking the map is position 1, 3. Okay. Well, program, I would like you to check at position 5, 5. Didn't do it. Program, check the position at 5, 5. It didn't do it. It did 1, 3 again. Program, please check position at 5, 5. It didn't do it. So I have to change this program to be able to check any position I give it. And obviously I'm not actually going to be talking to it. I'm going to be typing it. So I need to be able to input any 2 valid row and column. Now, how you go about doing that is up to you. Yep. Any other questions? Okay, I don't see any more. As I said this morning, I'm probably gonna hate myself for this, but homework will be graded within a week, which means that your Wednesday due homework will be graded by next time. Question is, how do we know when to stop? That's a good question. Does anybody know the answer to that? When you find the treasure. Yes. Now, how do you know when you found the treasure? Well, we don't have a loop, but the rest of what you're saying is correct. So let's say for one moment, yes, that's it. When the cell number equals the numbers given. Let's say for one, I'm going to edit the treasure map. Don't do this. I'm just doing it for an example. Is it okay if we use a loop? It's not a question for me. My guess would be no. Yeah, imagine how I feel. Um, I messed up this example here about square root 3 times, twice last semester and once this morning, because it's extremely difficult for me to try and write this without immediately thinking about doing just a bisection method. But anyway, I'm going to change this right here from 3.2 to 1.3. I'm going to run this on column 1.3. Ooh. Oh, I didn't run it. Checking the map of position 1.3, I get 1.3. This means I found the treasure because the input row column is the same as the output row column. Alrighty then. Well, I will see you all on Wednesday. Have a good rest of the day.